Okay, so I think this is recording. Yeah, okay. I want to review how to graph polynomials. I think you guys have probably done this quite a bit in Algebra 2, but we're going to use it to kind of then launch ourselves into graphing uh, ratios of polynomials later. So that's why I want to review it. So the example I want to start with is sketching this. F of x equals 5x cubed minus 5x squared minus 10x. Okay, remember polynomials, they have all real numbers for the domain, and they are continuous everywhere. So this thing is just going to be a nice, bouncy little roller coaster looking thing. And this one is nice because it can be factored without too much difficulty. So this is going to turn into 5x if I factor that out of everything. I'll get x squared minus x minus 2. And then I can factor that parentheses into x minus 2, x plus 1. Okay, so what can we do with that? In order to sketch it, I think it would probably be useful to find the x-intercepts or the zeros. Okay, so in factored form, that's easy. That's just whatever makes each factor 0. So in the first case, x is 0. It could be x is 2, could be x is -1. Any of those things get you 0 for the y value. To get the y-intercepts, we just let x equal 0. So if x is 0, when I plug that in right there, the whole thing turns into 0. So my y-intercept is y equals 0. If I wanted to see what happens at the ends of the graph, right, that's this whole thing. Let's see what happens when I examine as x goes to infinity of f of x. So f of x, right, we could plug in that whole function, but you're allowed to, for infinite limits, just look at the dominant terms, which in this case is just 5x cubed. And that's going to turn into infinity when x goes to infinity. And if I looked at what happens as I go to negative infinity, well, dominant term doesn't change, so it's still 5x cubed. That's going to go to negative infinity. So this means on the right side, because it's positive infinity, I'm going to go up like that. And on the left side, I'm going to go down that way. Okay. What else can we do? We've done sign charts a bunch. So let's take a look at the sign chart. Oh, just one. So here we go. We'll put the y values on top, the x values on the bottom. Significant things for a sign chart. When was the function 0? So it was 0 when x was -1. It was 0 when x was 0. And it was 0 when x was 2. There were no discontinuities in the graph. You would put places where there were like vertical asymptotes on there too, or holes, anything like that. But in this case, that's all we've got. Okay. So if I plugged in some test points, remember this is still f of x right here. If I plugged in some test points into this function, right, which is the original, just in factored form, I can quickly see what kind of signs I get. So like if I plugged in -2, right, well, this is going to be negative, this is going to be negative, that's going to be negative. 3 negatives multiplied together is negative. If I plugged in like -0.5, you end up getting a positive here. If you plugged in 1, let's say, you get a negative. And if you plugged in 10, you get a positive. Okay. So we've got a lot of information. We can make a rough sketch of this graph. So let's do that. I like to line up my graph right below my sign chart because I feel like it's just easier. 2 goes there. So there'd be a 1 here, -1, -2, whatever. Okay. Let's see. I know that the graph had to go through 0 to -1 for the x-intercepts. So 0 to -1. I know that the graph started out way down at -infinity, which makes sense because the graph has to be negative all over here. So below the axis, right? So something like this would satisfy. On the left it has to go down, and it's got to be below the axis all the way up to -1. And at -1 it's supposed to be 0. Then between 1 and 0 I'm supposed to be positive. So something like this, right? You might wonder why it doesn't go up like that. Well, when I get to 0 it's got to be 0, so it's got to come back down again. Then I go negative until I get to 2, and then it's 0 again. So negative till I get to 2, got to be 0 at 2, and then positive. Positive. And why doesn't it do this? Because it's got to go all the way to infinity. So it's got to go up like that. Okay. So the limitations of this is it doesn't tell you when you get your relative minimum or relative maximum, but you could just plug in some additional points, you know, some extra x values, if you wanted to see more detail to the graph. Just because it's between 0 and 2 doesn't mean that the low point is actually at 1. Only for quadratics can you use that symmetry. But at least it gives you a good idea of what it looks like. So, okay, hope that helps. And what I want to do is give you a second example. So here it is. X cubed plus 2x squared minus 4x minus 8. And if you want, you could try it positive first, seeing if you can do this by yourself, and then just you can fast forward it to the end and see if it works. One thing is this is factorable by hand. So you can factor out an x squared from the first two terms. Whoa. And you can factor out a 4, -4, from the second two terms. It's kind of like saying x squared times a minus 4a. So it's like x squared minus 4 times a if you factor out the a. And then x squared minus 4 is just x plus 2, x minus 2. And then there's this other x plus 2 at the end. So that's just x plus 2 squared times x minus 2. All right. So here's f of x in fully factored form. So from here, you might want to pause it, see if you can find all those things that we found out here. The x-intercepts, the y-intercepts, the ends of the graph, the sign chart, and then sketch it. So I'm going to do that real quick over here. The x-intercepts are plus and minus 2, because -2, +2. Y-intercepts, if you plug in x equals 0, you get y equals -8. The end behaviors, the ends, if you look at what happens when x goes to infinity, the dominant term is x cubed, so this goes to infinity. And then if you look at what happens on the other side, you get -infinity. Okay, so sign chart. All right, we got -2, we've got 2, those are our zeros. And in this case, it's actually going to be negative, negative, positive. Usually the signs alternate, but when you get a positive exponent for one of these factors, that actually, if you play around with it enough, you start to see why that leads to a bounce as opposed to cutting through the axis. So let's take a look at what this is going to look like. So 0 would go right down the middle. So -2, or +2, -2, let's do -4, 4. Let's go 4 and -8. Okay. So some of the points it has to go through: 2, 0, -2, 0. Those are the x-intercepts. Has to go through y equals -8. That's the y-intercept. Way out at infinity it's way up high, so that'll be somewhere over here. You know, we'll see. Way out at negative infinity, it's really low, right? Has to start out negative and get to 0. So it starts out negative, gets to 0, right? When x is negative 2. Ooh, forgot the x and f of x. Okay, then I stay negative. So I go back to being negative, and I go right through negative 8 because that's the y-intercept. Okay, I have to be 0 when I get to 2 again. So I got to curve this around back up to 2. And then I go positive, and remember, I stay positive as x goes to infinity. So that's a sketch of what this looks like. It's got a bounce in it at the x-axis. The reason is because this is squared. If it was cubed, it would actually cut through again. And you can kind of think about it a little bit and start to convince yourself why that's the case. It should make sense as you think about, is this side positive or negative, and what happens if you square that? So, all right, I hope that helps, and I'll see you guys soon.